manual refresh. To do a manual refresh, we use a built-in package which is dbms_mview. In that we have a refresh procedure which will do as a refresh. Execute dbms_mview dot refresh. It will accept two parameters. The first one is name of the materialized view. Second one is the type of the refresh option. C for complete, F for fast refresh. This is the manual refresh. So we are doing a manual refresh for MV_EMP2, I think. Let us check. Yeah, MV_EMP2, comma, we go for complete refresh. It is completed. Now let us check the table. Table is having 4 records, and check from the materialized view. Since it is already refreshed, this should have 4 records. Yes. Now the materialized view, select star from MV_EMP2 is having 4th record. Before it was not there, it had only 3 records. Now it is having 4 records, that is after performing a refresh. We are doing a manual refresh. It is complete refresh, but we are doing manually so that after the refresh we can see the changes in the materialized view. Let us do one more thing. Let us delete from EMP where EMP number equal to 1. Use a commit. So now the table is having only 3 records. 1 record is deleted. When we select from materialized view, 4 records are there. 4th one is still present. This change will be applied after the refresh. Now let us do a refresh. Again go for manual refresh. Execute dbms_mview dot refresh. Materialized view name and then the type of refresh. Complete refresh we go. Successfully completed. So now let us check the table. It is having only 3 records. Before the materialized view was having 4 records. Now it should have 3 only. The changes should be applied after the refresh. So we have done a manual refresh now, and after the refresh we are able to see the changes in the materialized view, whatever the changes that happened on the base table. Okay, let us create a temporary table now. One normal table. We don't want to spoil the data in the EMP table. Let us create one table, T_EMP, employee number, employee name, salary. Employee number must be primary key. Primary key is mandatory, so we are using primary key. Creating, let us remove this, creating our own table, T_EMP. Now we are creating one materialized view, MVT_EMP. Now we create, this is throwing error because primary key was not there. We added the primary key and we are creating the materialized view. Now let us insert some data into that. We just created a table, inserting the data. do a commit so that data will be saved. Yes, in the table we have 4 records now. There are 4 records in the table. Yeah, let us create this materialized view. Complete refresh, start with sysdate, means from this point of time sysdate plus 3 by 1440. 3 by 1440 is 3 minutes. From current time 3 minutes. After 3 minutes it will do a refresh. Materialized view created. Now let us select star from materialized view. It has data. Table is also having data, 4 records. Materialized view is also having data, 4 records. Because it will go for complete refresh at sysdate at this point of time. So after 3 minutes it will do a next refresh. Materialized view is created at 1940 or 1939. 19 minutes 40. So 19 minutes plus 3 is 22 minutes 40. So now it is 20 minutes. Another 2 minutes time is there. Let us delete from t_emp where employee number equal to 1. 1 row deleted. Commit. Now select from the table. It has 3 records. Select from the materialized view which has 4 records. Now let us wait some time. After 3 minutes it will do a automated refresh. Then we can see the changes that are applied in the materialized view or not. It is created at 1940, so 2240 it should become. It is only 2114. 2240. Almost another 1 minute to go. Exactly 1 minute. If we check from the materialized view, it is still having 4 rows. 1 record is removed from the base table. That record has to be removed from the materialized view. This will happen after the next refresh. This is 2204 only. After 2240 or 2239, 39 or 40 seconds, the changes will be, the materialized view will go for refresh. The changes will be applied. Another 9 seconds to go. 35, another 5 seconds. Yes, now if you run this, still it is same. Yes. See, exactly at, where is that? 2240, we are still having 4 rows selected because the refresh will take some time. At exactly 2240, the refresh will start. To complete the refresh, it will take some time because it is complete refresh. It will truncate and then it will do an insert from the base table. So for this refresh option, it may take 2-3 seconds. So when we ran at 2040, exactly it has 4 rows. The changes are not applied. Maybe the refresh is initiated, and when we run at 2244, the refresh is completed and the changes are applied here. So it might not have taken 4 seconds to complete the refresh. Maybe 1 second or 2 seconds or 3 seconds might have taken, maybe 4 seconds also, but we have not executed in between 42, 43 like that. We have executed at 44. So within that 4 seconds, the complete refresh is completed and the changes are applied in the materialized view. So we are able to see the changed data in the materialized view. Now we did not do the refresh manually. The refresh happened automatically. This is automated refresh. See, since now it is every 2 minutes, 22:40, next refresh will be 25:40. So we can 25:40, another 1 minute is there. Okay, update t_emp set ename equal to bb where enum equal to 2 and then do a commit. Now let us select from the table bb is modified. Select from the materialized view. The change is not reflected here yet because it is 2508. It is 2508. The refresh will happen 25:40. So another 15 seconds to go. So after that we can see the automated refresh, and whatever the change is present for record number 2, the change will be applied here. Means ename will be updated. Yes. See, at 43 also not happened. 47 it happened. So for 3 seconds also refresh is not completed. After 3 seconds means maybe exactly 4 seconds the refresh is completing. So after this refresh we can see the modified data here. So the data is modified because of the refresh. This refresh happened automatically. So we have seen the complete refresh in both manual refresh option and automated refresh option. Both the options we have seen with complete refresh. Next we move on to the fast refresh, and then we will see fast refresh automated and fast refresh manual. In this session we will see materialized view with fast refresh option. Let us see what is fast refresh. Fast refresh is nothing but incremental refresh. Means the refresh happens on the incremental data which is modified from the last refresh. So whatever the changes are applied on the base table from the last refresh, all those changes will be applied on the materialized view because of fast refresh. So when the refresh interval is very smaller intervals, in that case we go for fast refresh. Fast refresh, the name itself indicates it will be faster. Means the refresh will complete very fast because it is applying only the incremental changes, and since the changes it has to be applied are very minimal, that is from the last refresh only, the refresh will be faster here. How the fast refresh will apply the incremental changes? How the database knows what are the changes that are applied on the base table from the last refresh? That is possible through the materialized view log. So materialized view log is mandatory for the base table to perform a fast refresh on the materialized view. Means if we want to create a materialized view on a base table, before creating the materialized view there should be materialized view log on the base table. First we need to create the materialized view log on the table, and then we need to create the materialized view on the base table with fast refresh option. If the materialized view log is not present on the base table, the materialized view creation will be failed if we choose the fast refresh option. So to avoid this, we should create the materialized view log on the base table before creating the materialized view log on that table with fast refresh option. And if the materialized view is created based on multiple base tables using join, in that case we need to have the materialized view logs on all the base tables that are participating while creating the materialized view. If we are using 5 tables as base tables for creating the materialized view, then all the 5 tables should have the materialized view logs. And the materialized view logs, whatever we are creating, all those logs will be created on the database server, that is remote database server. Means on the database server where the base tables are residing, in that database the materialized view logs will be created, not in the local database. So always the materialized view logs will be created on the remote database where the base tables will be present. In that database server the logs will be created. Now when we have the materialized view log on a base table, whatever the changes we are applying on the base table, those changes will be recorded in the materialized view log. Now when the materialized view log is going for fast refresh, the database will be reading the changes from the materialized view logs, and then those changes will be applied. So this is how the fast refresh can implement only the incremental changes from the last refresh by reading the changes from the log file, materialized view log. In this materialized view log, there will be the records or the changes that are modified from the last refresh only. Once the refresh is completed, the materialized view log will be erased. That means materialized view log will be cleared. The log entries will be cleared. Log file will be there, but entries will be cleared. And again, if there are any changes, those changes will be logged into the materialized view log. So when it is performing the fast refresh, at that time it will read the log file, it will identify all those changes from the log file, it will apply those changes on the materialized view. Once the changes are applied and the refresh is completed, log file will be cleared, it becomes empty. So for the shorter refresh intervals, it is always advisable to go for fast refresh, because the changes will be minimal, so that it can be applied very soon. The refresh can be completed within seconds or minutes. So complete refresh is not advisable for smaller refresh intervals. Maybe hourly refresh, complete refresh may not be advisable, because the refresh itself may take 30 to 40 minutes or maybe even more than that. So in case of complete refresh, it will do a truncate and then insert. So complete data will be removed from the materialized view and a fresh copy of the entire data from all the base tables will be loaded into the materialized view. But in case of fast refresh, the existing data will be as it is and only the modified data will be applied on the materialized view. When we talk about modified data, this can be inserted records into the base table, deleted records from the base table, updated records on the base tables. All these 3 changes will be applied on the materialized view. Now let us see how to create the materialized view with fast refresh option, and how do we refresh the materialized view in fast mode with manual effort. Means manually how do we refresh the materialized view in fast refresh mode. Yeah, fast refresh. We have created one materialized view in complete refresh option, which is MVT underscore EMP2. This is the materialized view which we have created earlier. This is created with complete refresh option, and the base table for this materialized view is T underscore EMP. Now let us try to refresh this materialized view in fast mode manually. Actually, this materialized view is created with complete refresh option, but manually we will try to refresh this materialized view in fast refresh option. Let us try. We use dbms underscore mview package to perform the refresh on materialized view. We need to specify the materialized view name and then the mode. We are refreshing MVT underscore EMP2 in fast mode. So let us execute this. We got error. Scott.T underscore EMP does not have a materialized view log. That means to perform a fast refresh, the base table should have a materialized view log on that. Then only it can read the changes from the log file and it can perform the incremental refresh. Since log file is not there, fast refresh mode is not allowed on this materialized view. Okay, let us create a materialized view on the same table with fast refresh option. Create materialized view MVT underscore EMP4, refresh fast, start with sysdate, means first refresh is now, next sysdate plus 3 by 1440, next refresh, subsequent refreshes will be every 3 minutes, as select star from T underscore EMP. We got error message, table T underscore EMP does not have a materialized view log. Since the base table does not have a materialized view log, creating materialized view is throwing an error message. So we cannot create a materialized view on a base table which does not have the materialized view log on the base table. So now we need to create a materialized view log on this table before creating the materialized view on this table with fast refresh option. So create a materialized view. Create materialized view log on T underscore EMP. Create materialized view log on table name. Materialized view log created. Now if you try to create the materialized view with fast refresh option on T underscore EMP table, it will succeed. It will check for the materialized view log on T underscore EMP. If it is there, it will create. If it is not there, it will throw error message. Previously we got error message because materialized view log does not exist on base table. Now we have created it, log is there, so it should succeed. Materialized view created. So it will do a fast refresh. See, when we did this refresh for 3 minutes, in earlier case complete refresh, it was taking 3 to 4 seconds. Now let us see how much time it will take for the fast refresh. Now select data from this table. It has 3 records. Select data from materialized view MVT underscore EMP4. This has 3 records. Now insert into T underscore EMP values 5, comma E comma 500. One record is inserted. So now committed, check from the table should have one extra record which is 4. Materialized view will have only 3 records till the next refresh. See, we have created the materialized view at 45:05 seconds. So next refresh will be 3 minutes, that is 48:05. It is 47:08, so approximately 1 minute. 48:05 seconds, the refresh will start. The refresh may take 2-3 seconds. After that, we can see the changes that are applied on the materialized view. We need to wait till 48:05. Changes are not yet applied. We are close to that. It is 3 rows only at 06. 11 also 3 rows. It is not happening. MVT underscore EMP4 fast refresh, start with sysdate plus 3 by 1440, 24 into 16, 24 into 6 is 144, 11440. Select start from TEMP. Did we commit or not? We have inserted into T underscore EMP, committed. TEMP is having 4 records. MVT underscore EMP4 is having, yes, it is having 4 records now. Fast refresh has taken longer time. I don't know how much time it has taken. Yeah, refresh is completed automatically. So till 48:19 it was not completed. 49:15 it is completed. So our expected time is 48:05 to start. So 49:05 is 1 minute 10 seconds. When we checked it, it is applied. Okay, let us insert one more record. We are inserting one more 5th record. Unique constraint is there. Okay, insert 6 F600. Missing, comma is missing. Completed, commit completed.